Hello students. Students, today we will discuss Ohm's law from this chapter number 12, electricity. Today's topic will go like this. First we will recapitulate what we have studied in this chapter till now. Then we will discuss about Ohm's law, numericals on Ohm's law. Then we will assess what we have studied today. Then we will summarize today's topic and in the last, homework. So this topic, Ohm's law, has three new terms. First one is current, second resistance, third is potential difference. Now what is current? The rate of flow of charge is known as current. The rate of flow of charge is known as current. The SI unit of current is amperes. Current is represented by capital I and its SI unit ampere is represented by capital A. Resistance. The second new term is resistance. Resistance is to resist. That is, it is obstacle. It obstructs. Now in this chapter electricity, what will be the obstacle? The obstacle will be to the flow of charge. तो जो भी रेजिस्टेंस होगा वो किसी न किसी ऑब्जेक्ट का होगा जो चार्ज को अपने थ्रू फ्लो नहीं होने देगा. इफ़ द वैल्यू ऑफ रेजिस्टेंस इज़ हाई, यानी रेजिस्टेंस की वैल्यू बहुत ज़्यादा है, दैट मीन्स द फ्लो ऑफ चार्ज, फ्लो ऑफ करंट थ्रू दैट पर्टिकुलर ऑब्जेक्ट विल बी minimum, or you may say low, or no amount of current, that is no current will flow through that object. Such objects which are having very high amount of resistance, you may say infinity, those substances are known as insulators. Those are bad conductor of current and electricity, such as wood, plastic, air. They are bad conductor of electricity and their resistance is very high, you may say infinite. So what about those substances which are having low resistance, which offer low resistance or less resistance to the flow of current through them? So the substances which are having low resistance, they are known as conductors. Those are good conductor of electricity. They allow current to pass through them easily. So these type of objects or substances are known as conductors and they are having low resistance. The SI unit of resistance is ohm. Next is potential difference. As the name suggests, difference, it is the difference between the two points of a current carrying circuit is having different potentials. Then you may say that there is potential difference between 2 points and current will flow from higher potential to lower potential. Say in a circuit there are 2 points A and B. So the potential at point A will be VA. Potential at point B is VB. If the voltage at point A is higher as compared to voltage at point B, VB, then current will flow from point A to point B, that is from A into the direction of B. And hence there is a potential difference, VA minus VB. What if VB is greater than VA? The current will flow from point B towards point A and we will say VB minus VA. VB is greater than VA. And what if both the voltages at point A and point B are same, VA is equal to VB? Then there will be no flow of current, as if both the potentials are equal. VA minus VB is 0. And the unit of potential difference is those same of potential, that is volt. Potential is also known as voltage. So here we come to the recapitulation. In the last class we studied about charge. What is charge? Flowing charge is known as current, and rate of flow of charge is known as electric current. It is represented by I and the SI unit is ampere, and which is represented by capital A. The circuit is of two types, closed and open. In a closed current carrying conductor, this closed current carrying conductor loop will be having some elements, and these elements and this current carrying conductor will be called as a circuit. And if the circuit is open, then you all know there are minimum 5 points. Any one statement may be true from these 5. That is, the indicator, which is bulb, may be fused, there may be loose connection, there may be cracked wire, the switch may remain open, and the fifth one is the battery or the cell, the potential providing to the circuit, the battery is dead. The circuit will be known as open circuit, and bulb will not glow, as you can see in the figure. The electric potential difference between 2 points in an electric circuit in which current is flowing, some current is the work done to move a unit charge from somewhere to a point near another charge. जैसे मैग्नेट को दूसरे मैग्नेट के पास लाते हो तो अट्रैक्शन और रिपल्शन होता है, उसी तरह से चार्जेस आर ऑफ टू टाइप्स, पॉजिटिव एंड नेगेटिव. Positive charges repel each other, negative charges again repel each other, and positive negative attract each other. Now here are the symbols of few elements. First one is electric cell, one plate small, another plate large. Second one is battery. It is a combination of cell in a particular way, and this fashion is one plate of cell is connected to another plate of another cell. Which plate? Positive plate will be connected to negative plate, and the second cell's positive plate will be connected to the negative plate of the third cell. So here are 3 cells forming a battery. Next one is a switch, which is open, plug key. Next, fourth one is switch closed. Fifth one is wire joining, or you may say junction. Sixth one is a wire crossing without joining, or you may say jumper. Seventh is bulb. Eighth is the symbol of resistance. Ninth, variable resistance or rheostat. 10th one, a circle having alphabet capital A is known as ammeter. 11th, voltmeter, represented by a circle having capital V inside it with 2 terminals. And 12th one is fuse. So here are the practical pictures of these components. These are the pictures which are used in the circuit which we have to draw on our book or notebook. And these are the elements which we see in our daily life. So the first element, this one is resistance. This is resistance. This element is capacitor, represented by C, capacitor. Next element, this is diode. This one is a transistor. This is IC. These are also ICs. Integrated circuits is the full form of IC. This is a copper coil winded over a soft iron core, copper coil. These 3 are the switches. This is a very common, you all know, LED, light emitting diode. This is relay. Relay is a magnetic switch, magnetic on off, and this is, you may find out in each and every electrical appliance, electronics appliance, fuse. So coming to today's topic, Ohm's law. Ohm's law was given in 1827 by a German physicist, George Simon Ohms. He found out a relation between a current carrying metallic wire and the potential difference across the end of these wire. And he came up with a definition that an electric current flowing through a conductor is directly proportional to the potential difference across its end, providing physical conditions remains constant. What are the physical conditions? Pressure, temperature, etc. If these physical conditions remains constant, then the current flowing through the circuit is directly proportional to the voltage applied across the circuit. So from here you can say that V is directly proportional to I, and if we remove the sign of proportionality, then we have to introduce constant of proportionality, and the formula becomes V is equal to IR, where R is constant of proportionality, which is also known as resistance of the circuit. Here V is voltage, I is current flowing through the circuit, R is resistance of this circuit. So from here we come to a conclusion and we write V, I and R in form of a triangle. In further slides you may see the benefit of this triangle, where V represents voltage, I represents current, R represents resistance. And here is the formula: I is equal to V by R, or V is equal to IR. The unit of current is amperes, represented by capital A. So here is Ohm's law. Ohm's law gives us a formula V is equal to IR. So if you have to find out V, then if you are finding out V, then I into R. V is equal to IR. And if you are supposed to find out I, then V divided by R. And if you are asked to find out the resistance of a given circuit, then it will be given by V by I. So we write in this fashion: this triangle, where V is in the upper part, I and R in the lower part, left and right. V is equal to IR, I is equal to V by R is equal to V by I. So what is R? R is the constant of proportionality, and it is known as resistance. Its SI unit is ohm, which is represented by this symbol. This is the symbol of ohm. Resistance is the obstacle to the flow of charge through conductors. And if the potential difference across the two ends of a current carrying conductor is 1 volt, potential difference is 1 volt, and the current through the conductor is again 1 ampere, then the value of R through of the conductor is 1 ohm. You may say that R will be 1 ohm if V by I, that means V is equal to 1 and I is equal to 1, 1 divided by 1 is equal to 1, hence the value of R comes out to be 1 ohm. I again repeat, V is equal to IR, R is equal to V by I, and I is equal to V by R. Now here is the graph of Ohm's law. In Ohm's law, the devices which follow the Ohm's law. What is Ohm's law? That the current is directly proportional to the voltage across the two terminals of a current carrying conductor. Given physical conditions constant, the devices which follow this law are known as ohmic devices, and it is always a straight line between C versus V graph, current voltage graph. It is also known as IV graph, current graph, voltage graph, current versus voltage graph. So these devices are known as ohmic devices. Resistance is constant. And what if resistance changes? If resistance changes, then these devices are known as non-ohmic devices, and the current voltage graph, I versus V graph, will be a non-linear path. It may be any curved. This is of non-ohmic devices which do not follow V is equal to IR, Ohm's law. So what is charge? If current is there, there must be charge. Charge is the basic property of the matter which is responsible for all the electrical and magnetic interactions of that object. You all know the SI unit of charge is coulomb, and there are two types of charges, positive and negative, and charge is represented by Q. The charge on electron is minus 1.6 into 10 raised to power minus 19 coulomb, and charge on a proton is 1.6 into 10 raised to power minus 19 coulomb. Both the charges are same in amount, but one is negative and another is positive. That's why the naturally occurring material around us doesn't possess any current naturally, because the number of electrons and number of protons in that particular object are same. No doubt both are having charges, but they cancel out each other as if the amount of charge of electrons and total amount of charge of protons is same. The number of electrons or protons of a body are same. That is why a body is neutral as a whole. Neutral as a whole. It is given by a formula Q is equal to Ne, where Q is charge, N is number of electron, and E is charge on an electron. If the Q is positive, then E is considered as plus 1.6 into 10 raised to power minus 19, and if the charge is negative, then E is considered as minus 1.6 into 10 raised to power minus 19 coulomb. Now here is the relationship between charge and current. We all know the rate of flow of charge through a particular point in a circuit is known as current. So I is equal to Q by T, where I is current, Q is charge, and T is time. So let us consider a numerical where you have to find out any one of these three. If you are supposed to find out a voltage in the given circuit, then you are having current and resistance. If you are having current and resistance, then formula will be V is equal to IR. Here I is 2 ampere and current is 2 ampere, resistance is 12 ohm. V is equal to IR, we get 24 volt. And what if you are supposed to find out current and voltage and resistances are given? Then if you are finding out current, I is equal to V by R. Then 24 divided by 12, 24 is voltage and 12 is our resistance. 24 divided by 12, we get 2 ampere. The current flowing through the circuit is 2 ampere. And if you are supposed to find out the resistance, then R is equal to V by I, where V is 24 volt and I is 2 ampere given in the circuit, and by the formula R is equal to V by I, you get 24 by 2, 12 ohm. So 12 ohm will be the resistance of the circuit. Now here is a straightforward numerical for you. In this numerical, resistance of an electric iron is 48 ohm and the current flowing is 5 ampere through it. Find out the potential. So you are supposed to find out V. I is 5 ampere and R is given 48 ohm. So from the formula V is equal to IR, you just multiply resistance and current as if both are in SI units, and we conclude 240 volt is the answer, is the potential across this electric iron. So here we come to the today's assessment. First question, calculate the resistance. You have to find out R. If 5 ampere of electric current, the value of I is 5, flowing through a conductor having potential difference between 2 point equal to 15 volt, the value of V is 15 volt, and the formula will be, you have to find out R. The formula will be R is equal to V by I. Okay, now put the values of voltage and current, you will be having your resistance. The second question is, if the potential difference across electric motor is 220 volt, the value of V is 220 volt, and an electric current of 5 ampere, the value of I is 5 ampere, and you are again to find out resistance. R is equal to V by I. Here the voltage is 220 volt and current is 5 ampere. Use the formula R is equal to V by I and find out the resistance. The third question, here current is given 15 ampere, which is flowing through an electric fan, and potential difference is 240 volt. V 240, I 15 ampere. So the value of resistance R is equal to V by I, 240 divided by 15, and the result will be in ohms. So here we conclude today's topic. Now according to Ohm's law, it states that voltage across two terminals on current carrying conductor is directly proportional to the current flowing through that conductor. V is equal to IR, or you may say I is equal to V by R, or you may say R is equal to V by I, where R is the obstacle to the flow of charge through this current carrying conductor, and the SI unit of resistance is ohm. 1 ohm is equal to 1 volt divided by 1 ampere, and the variable resistance is known as rheostat. So once again, V is equal to IR, I is equal to V divided by R, and R is equal to V divided by I, where V is voltage, I is current, R is ohms. The SI unit of voltage is volts, the SI unit of current is ampere, the SI unit of resistance is ohms. So with this we conclude today's topic, and here is homework for you. Solve the given assignment. Thank you and have a nice day.